Math 1, Ready, Set, Go, 9.6. So first kind of just some finding distances and averages. Find the distance between point A and each of the points on the number line. So A would be right here. So A and F, A right here at 11, F at 4, 11 minus 4, or we count 1, 2, 3, 4, 5, 6, 7. Okay, A and C, 1, 2, 3, 4. A and G, 2, A and B, 1, A and D, 1, 2, 3, 4, and A and E, 1, 2, 3, 4, 5, 6. Okay, so what is the total of all the distances from point A that you found? So if we add them all up, 10, 24. Find the average of the distances that you found. So 24 divided by how many we had? 1, 2, 3, 4, 5, 6 would give us 4. So the average distance was 4. So which point or points on the number line is located the average distance away from 4? C, and then D. Circle the location or locations on the number line that is the average distance away from A. So just circle there and there. Okay, now it says find the distance between point D. So let's clear that off now. So now we're looking at D. So E is 2, DE, so that'd be 2. 1, 2, 3. DB is 3. DA would be 4. DG, 5, 6. DG, 7, 8. And DF, 9, 10, 11. Okay, so once again, kind of doing the same thing. What is the total distance? Well, we add those up. 10, 20, 31, 34. Find the average distance. So 34 divided by 6 would give us probably a decimal, right? 5 point something. Gives us about 5.7 when we round. 5.6666666, but we round and it's 5.7. All right, is there a point? Okay, that distance away, 5.7. So from D to the right, 1, 2, 3, 4, 5.7. To the left, 1, 2, 3, 4, 5.7, about right there. G is close to it, but it's not. So label it Y. This one's off our number line, so we won't worry about it. So we'd label that one Y. Okay. Now it says create a scatter plot from the data of table. So if we notice, first thing, we've got some pretty big numbers here, right? So we're probably going to want to count, we're not going to want to count by ones on our scatter plot. So maybe we could count by fives. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. Okay, and that would be our English. We'll label this the English. And we'll label here the history. We'll count by fives again. Oh, I suppose we should have counted this as 0, huh? So 10 would, so 0, then 10, 20, 30, 40, 50, 60, 70. So same way on the other one. So 0, then 10, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. Okay? So then we plot our point, 60, 65. So 60 would be down here. Then 65 be right there. So there's our first point, right about there. Then 53, 59. So 53 up to 59. So 53 would be a little past 50, 59 almost to 60, right about there. Okay. Then 44, 57. So 44, 57, about right there-ish. 61, 61, right about there, and then 70, 67, right about there. Okay, so do English history scores have a positive or negative correlation? Well, we can see it's kind of going up in this direction, so we'd say a positive. Do they have a strong or weak correlation? So what would that correlational coefficient be? Well, if we look at the correlational coefficient, that's almost a straight line. So it'd probably be like 0.9 something. So it's very strong. Okay, so that's all it was asking us to do on those ones. So 14, looking at A, B, or C, which one gives us the best model? Which line? So this one goes through a couple points, but it's going way up here. This one we're below a bunch. This one looks like it's more the average, so I'd go with C. Okay, 15, same idea with exponential. Once again, a linear wouldn't work because this is going up this way. This one shoots up too soon, so it would have to be B. And 16, definitely looking at that, it's definitely not linear. This one kind of goes down a little too far. It looks like A would be the best. Okay. Now for the Go is kind of a review here. So it wants us to create an explicit function rule. So remember, explicit means it's like f of x equals something x. Common difference means we're adding. Ratio means we're multiplying. So this one says f of 2 equals 7 with a common difference of 3. So the idea would be to make a table. So a 0, 1, 2, a 2, or a 7, common difference of 3. So we're adding 3 each time. So if we go backwards, that would be 4, that would be 1. Now for explicit, remember, we go f of x equals, because it's f of 2, our starting number, 1, then our common difference, plus 3. That's the one that changes, so we put the x next to it. Okay, number 18. Let's actually do all the common differences first. So 21 and 20. So 20, we have r of 5 being negative 3. The difference is 7, so we're adding 7 each time. So this would be negative 10, negative 17 going backwards, negative 24, negative 31, negative 38. So we'd go r of x equals our starting number, negative 38, plus 7x. So 21, same idea. So 0, 1, 2, 3, 4, 5, 6, 7. At 7, we're at 1. We're subtracting 9 each time, so I'd go opposite and add 9. So 10, 19, 28, 37, 46, 55, and 64. So we'd go g of x equals 64, our starting number, then minus 9x each time. Okay? And that's how we do those linear ones. We know they're linear because we have a common difference. We're adding or subtracting each time. So now for our common ratio ones, okay, so it was 0, 1. G of 1 is 8. Common ratio 2, so we're timesing by 2. So what number times 2 is 8? It's 4. So I go g of x equals my starting number, 4. What are we doing? Timesing by 2. We're timesing. So we put the x up above. Okay. Then 19. So we go to 6. So 0, 1, 2, 3, 4, 5, 6. It's 3. Our common ratio is timesing by a negative 3. So we're kind of going backwards. Okay, so 3 divided by negative 3 would be negative 1. Divided by negative 3, negative or positive 1/3. Negative 1/9. Basically, we're timesing the denominator by 3. Positive 1/27. Negative 1/81. Positive 1/243. So h of x equals our starting number, positive 1/243 times negative 3 to the x. And then our last one, g of 1 5. Common ratio of 1/2. So the opposite would be dividing by 1/2, which is the same as timesing by 2. So we'd go g of x equals 10 times 1/2 to the x. And there we go, guys.